All right, this is our last video. So we're going to do just a little shortened version of chapter 10. Only going to really teach you the bare minimum because we don't really have time to get into it, and there's only like one or two questions on the final about it. So I'm giving you the short and sweet version. So there's one long calculation that we'll have to do, but other than that, we don't really have a ton to do. Okay, so scatter plots, correlation, and then regression. So there's a whole class on regression in college. So if you are going into some field that you're going to have to use regression, and they may have you take a linear regression course. This is something that you may have been introduced to in the past. So correlation is just determining whether a relationship exists between two or more numerical or quantitative variables. So you could say, are two or more variables linearly related? What is the strength of their relationship? What type of relationship? And what kind of predictions can be made from that relationship? So we're not going to actually go through and do the hypothesis test for that in our shortened version, but we could answer that using a hypothesis test. So these are some examples of correlations. Is the amount spent on advertising related to sales? Is temperature related to homicide rates? So there's independent variable, dependent variable. We've already talked about these several times during this course. X is the independent variable that can be controlled or manipulated. Y is what happens. It's dependent on the independent variable, so it can't be controlled or manipulated. So if we have two variables like level of education and salary, the thing that you have more control over is your level of education. That's your independent, so you can get more education, and that's going to increase your salary potentially. Height of a basketball player and the number of points scored. The height is your independent. Number of points scored is your dependent. So if we're saying that there's some relationship between if the players that are taller score more because they're closer to the basket or whatever it is, independent, dependent. And then political affiliation of wives and that of their husbands or partners or whatever. It could really go either way. One influences the other, or not. We're just trying to figure that out. Okay, so I thought I made this smaller, but I guess I didn't. A scatter plot is a graph for ordered pairs, so we're not going to actually make scatter plots, but we just plot we've done this before, we plot the X and the Y, and this would be a positive linear relationship here. This is a negative linear relationship, and then if it is, let's see here, let's make that, there we go. Let's erase that. You could have a curvilinear relationship, or you could have no relationship. So that would just be more scattered. And it could be like if you have lines that are, it looks like a linear relationship, but maybe the points are further apart. It's just not as strong of a relationship. Okay, so the measure is called the correlation coefficient. It's used to determine the strength of all linear relationships. So there are several types, but we use the Pearson product moment correlation coefficient. And so the population one is rho. It looks like this like P thing, but Greek letter rho. It's the correlation if you had all the possible pairs taken from a population. But again, what we use to estimate that, our sample, is R. So if you took AS Algebra 2, you talked about R values, and that is going to give us the strength of a linear relationship. So R can be between -1 and 1. If it's close to 1, then it's a strong positive linear relationship. So as X goes up, Y goes up. If it's close to -1, it's a strong negative linear relationship. So as X goes up, Y goes down. So it's an inverse relationship there. And then if it's close to 0, so the closer to 0 it is, it's a weak relationship, or it has no linear relationship. So the data points get further apart. Our assumptions for R, the samples were random. The data pairs fall approximately on a straight line, so that we are able to find a linear relationship. If we have this curvilinear relationship, then we wouldn't want to use linear regression. We'd want to use a different type of regression. And then the variables have a bivariate normal distribution. So you don't really have to know that. That's just our assumption. So R is going to be rounded to 3 decimal places, and it's very sensitive to outliers. It's going to change your value quite a bit. Okay, so this is our formula for correlation coefficient. Your R value, when you calculate it by hand, is very complicated. So we normally don't do this by hand. We usually use a calculator. But part of the curriculum is to know how it is computed. So we're going to do this one. We're not going to do the linear line regression line, sorry. So just R, so bear with me. There's like going to be a table that we use. But typically you're going to use a calculator to find your R value. N is the number of data pairs, and there's no units associated with R. It'll just remain unchanged if X and Y values are switched. Okay, so here's our data. The following data obtained in a study of number of absences in the final grade of 7 students in a statistics class. Assume there is a linear relationship. So here are my students. The linear relationship that we're trying to see is probably if you have more absences, then your grade is going to be lower. And these spots right here are supposed to be, this is supposed to be x, y, this is x squared, this is y squared. Okay, so we need a bunch of these values to compute that formula. So I know it's a bear, but you can do it. Okay, so x times y, we take the x column times the y column. So 492, this is 172, 645, 666, 696, 450, 624. And then x squared, so we take the first column squared. So 36, 4, 225, 81, 144, 25, 64. Then we're going to take y squared. And 7,396, 1,849, 5,476, 3,364, 8,100, and 6,084. Okay, and then we need to find the sum of all of these things. So we need the sum of the x's. So that's our total. So we add them all together, we get 57. We add all of our y's together, and we get 511. We add the xy, we get 3,745. I'm going to change my color here. we add the x squareds, and we get 579, and we add these and the y squareds, and we get 38,993. Okay, so now we're going to use those values. I'm going to add another page in here. My r is n times the sum of x, y minus the sum of the x's times the sum of the y's, all over the square root of, we have n times the sum of the x squareds minus the sum of the x's squared. So remember that that's two different things. And then n times the sum of the y squareds minus the sum of the y squared. Okay, so there's a lot going on there. Our n was 7. Sum of the xy's, we had 3,745. The sum of the x's was 57 and 511 for sum of the y's. Then we have n times the sum of x squared. That's 579 minus the sum of the x's, 57 squared, times 7 times the sum of the y squareds. That's 38,993 minus the sum of the y's squared. And when we compute that, we get negative 0.944. So that is our correlation coefficient. So what that means is that there's a pretty strong negative correlation, meaning that as the number of absences goes up, the grade goes down. So it's pretty close to -1. So that's your R value. That's what it means. The other thing to know is that that also shows you, like, if it's a negative R value, then it's a negative slope. Okay. And so that's the regression line. So we're really just going to look at the basics of this. We're not going to find the regression line. So after we determine if R is significant, so what you would do is we find our R value, and then we check to see, we do a hypothesis test and see if it's a significant R value. We don't have to learn that right now. And then after you know that it's significant, then you find the regression line. So that's the line of best fit. There's many lines that can be drawn close to the data, but then you find the one that's best fitting the data. You're minimizing the distance between all of the dots and the line. So slope-intercept form of a line is y equals mx plus b, but not for this class. We use y prime equals a plus bx. So a is the y prime intercept. So that was our b in the last one, and b is the slope. So that was our n. And so notice that that slope of the line is going to, if it's like my R value is negative, my slope is going to be negative. This is your formula for the regression line, but we're not going to do it. Okay, so I just wanted to show you that part. And this is all something you can find on your calculator too. So it's not really hurting you to not learn that this year. So there's a homework assignment on Schoology, and what I would do is, so there's some things I left out, right? So I tried to assign problems that I could, that you would know how to do everything. And so there's one that to find R, but it has you find it another way also. Just ignore that. I'm not going to like count off for that and stuff. Like, I'm not going to count that assignment, but you should practice that for the final because that problem's on the final. Okay, so thanks for watching my videos. You made it through the class. Good job. So now next thing you have to do is study for the final. Please let me know if you're having any questions. And it was so great to have you, even though I can't see you in person. So, all right, good luck.